Hello everyone, welcome to Handmade Hero Show where we code a complete game live on stream. We are probably, and I'm loath to say it, I know that it's a bit dangerous in there. It's dangerous to go alone. We are at the point where I kind of would like to start looking at the lighting and getting that into a shippable state. We did a bunch of work on it. We got something that's all right, but it's not quite there yet. It's not quite something that I think we could ship reliably. It's too slow, and it has some issues. I think it would be hard to use to light our sprites the way we want to. So I guess what I would say is I think now might be the time to go in and clean that up. And one of the reasons I say that is because we're getting pretty close to what I would consider a graphically complete looking sort of game. And the big problem right now is that the lighting just isn't there. And two things. One, you can see our sprites aren't lit, so they look stupid. All of this stuff is lit properly, and the sprites aren't. You hop into a dark area, you don't get darker, right? And that's not a huge problem to solve. Like, we could take our current lighting system and solve that. But it's not ideal to solve in the current system, so looking at how we want to change that's one thing. And then the other thing is it's just too slow. Like, we already are just doing a sub-region, you can see here, that's not quite big enough because you can see the edge of it when we zoom out a bit in things where we want to be zoomed out a little bit more. So that's a bit of an issue, but also we have the issue that in general, even in this sort of smaller state, in a fully optimized build on a modern machine, this machine's pretty fast. It's not the fastest, but it's pretty fast. It's sucking down like all of our time. And it's sucking down so much time that even things that kind of need to be optimized, like render ground cover, is made to look small and insignificant by comparison. I mean, here's 1,600 calls to a relatively inefficient routine, and that's only taking 4% of our time. And why is that when it's so piggy? And the answer is just, my good lord, compute light propagation just eats all the time. Why does it eat so much time? Well, because it's actually using the entire CPU. We've got, I guess six. Is it six here? 1, 2, 3, 4, 5, 6. We've got 6 additional threads, including the main thread. So all the cores of the processor minus 1, which we leave for, handling, sort of servicing other stuff at the time, like OS garbage and stuff like that. We're using almost all the resources of the CPU, and we're still getting a pretty lousy throughput on a not even in like particularly large swath of the world. And so, that's not the kind of thing that we really want to have in here. And furthermore, that's before it even has to do anything. Before we've made any accommodations for lighting our sprites. So it's a bad situation. It's not something where we just really don't want to see this. It's going to create problems for us, and we need to be more judicious as we go here. Okay. So let's talk about where's the slowness coming from? What's the actual problem? I don't remember. Yeah, we're not really printing out much in the way of stats right now. But, what's going on? Like, why are we so slow? And what can we do to speed it up? We got issues, right? We got issues. Too much time spent in the lighting, even though we've thrown all the CPUs at it. So first of all, let's start with a couple basics. It's not a parallelization problem. We're not locking or anything else. We've perfectly segregated, if I remember correctly, the lighting computation such that it actually fans out to all the processors with no locking. So it's not the kind of algorithm where our problem is just a subtlety of the multi-threading or something like that. We're multi-threading it pretty well. I mean, obviously, you can always probably do a little bit better. But it's pretty darn clean the way that it's being multi-threaded. So the issue, for us is beyond the multi-threading. So I think we can safely put that aside and say that's not what we're looking at here. Okay, thing two, GPU versus CPU. So the operation that we're doing, which is our ray tracing here, we're doing entirely on the CPU side. Obviously, for these kinds of operations, GPUs have a lot more floating point power backing them up. We could probably get a good speed up by switching from the CPU to the GPU, but not as good as the kind of speed up that we would expect if we were moving a traditional rendering operation over the GPU. And the reason for that is just because the GPU is not as good at arbitrary calculations involving arbitrary memory walking as compared to the CPU. CPUs are set up for that, GPUs are not, at least until you get to, for example, the RTX stuff, like with NVIDIA, where the chip is more optimized for it, and you use very specific algorithms that are designed to minimize the degree to which the GPU gets hurt by that fact. So, could we make some headway by moving GPU? Yes. I think that's true. We would have to probably modify our algorithms a little bit, but that wouldn't necessarily be the end of the world. And we definitely could get a speed up by moving it to the GPU. However, that would put a very high load on the GPU. We're already demanding a lot from the GPU because we're doing a lot of high quality fill work. We're using it to do order independent transparency and things like this, and multi-sampling and all this stuff. We're kind of wanting to use our GPU for actual rendering. And so using the CPU, which we do not need for anything else really. Our game doesn't do physics simulation in any kind of really extensive way, and so we're not really anticipating putting a high stress on the CPU for other things. We don't have thousands of characters walking around on the scene or something like that. We don't have a lot for the CPU to do, and we've been pretty efficient with our CPU usage, right? We haven't done stupid stuff. We've done some stupid stuff, but not stupid enough. And so utilizing the GPU has some downsides, which is to say that we're leaving the CPU kind of not doing much at all, and we're putting a lot of stress on the GPU at that point. And I don't know that that's necessarily the best way to go either, right? So there's some issues there I think that are worth keeping in mind. However, that algorithmic change is worth understanding, and it's worth understanding that there's more we could do algorithmically with our CPU version as well, just in terms of how we're like associating rays and casting them and things like that. There's probably more we could do there as well, right? Okay. So that brings us to the final point, which is the one that I actually want to focus on today, which is, do I realistically think our problem is just implementational like that? Like, how did we actually type the code in? Versus, are we just fundamentally doing some things wrong in the algorithm that if we fixed them, we would get a lot faster without really having to worry about particular details in the implementation themselves? And that's really the thing that I want to focus more on, because I think the answer there is probably yes. So I guess what I'm saying is, I think our approach should be improved first, because I think we can, by doing some things smarter than what we're doing right now. And if we improve the approach, I think we may get to a point where doing it on the CPU is actually fine, and we don't have to worry about it anymore. At which point we don't have to worry about improving the algorithms and transferring them to the GPU, which is more error prone and requires a much beefier GPU, because when we go to optimize our renderer for lower, whatever our lowest end system ends up being, it's going to be a lot harder to do if we've got to have a huge ray tracing pass on there in addition to everything else we're doing, right? So I think the thing that I'd like to focus on first before we do anything else is I'd like to figure out what we're going to do algorithmically different from what we're doing right now. And I think just based on kind of a, more passing familiarity with what the state of the art is in the higher end rendering world. So not Handmade Hero, but you're writing the next Doom or the next, Grand Theft Auto or something. The next Battlefield 6 or whatever. And you've got a whole rendering team and you're sitting there doing everything you can to max out the visual quality of this game that you're working on. Looking at the way that they do things, I think there's one pretty major change that we can make that would improve our quality a lot, I think, for the same amount of work that we're doing. Or maybe I should say it a little bit differently. It would improve the speed at which we can arrive at roughly the same thing we're looking at now, while at the same time making it easier for us to light our sprites cheaply. And so I think that that's probably the thing I would focus on. And I do think earlier on I didn't really do I didn't really consider this as a way to do things, largely because I think I didn't quite have a handle on how you would do it in real time as opposed to pre-computed, but I think I kind of get that more now. And so let me talk a little bit about this. And it's not a huge change from what we're doing actually, but it makes enough of a difference just because of a subtle change in the way you think about what you're doing. It does have a pretty, I think, or could have a potentially large effect on what we're doing. So let's talk about it. Okay. So what I'm talking about is light probes, and you see them around a lot. And the question is, can they work for us? Why am I mentioning them? What would be the difference between what we have now and them? Why do I think that this is a thing that we should investigate as our first attempt at making our lighting solution more shippable and less experimental? Okay. So what a light probe is, honestly, you could even use that term to describe what we're already doing in a sense, although I'll say why the term is traditionally applied to something slightly different. So let's talk about sort of like an ours versus theirs kind of a thing in terms of light probes, and with an eye towards why theirs is better than ours, I think. And then we'll also say, because I was aware of light probes when we started, and I'll also talk about why I didn't immediately choose to do them, and sort of why I think that maybe even my original reasons for not doing them are not warranted. Okay. So the way we currently do things is we sort of do light probes, in a sense. What we do is we have surfaces in the world, right? And those surfaces, because we're sort of going for a tiled aesthetic, tend to be kind of cube-like. They're not exactly cubes. It's not like Minecraft. They're arbitrary rectangular, right rectangular prisms. They can be any sort of shape. And they can be rotated as well and all that. But they are fundamentally rectangular solids. So we know that we've got sort of these quad faces, like this sort of thing. And we know that on each of those quad faces, what we're going to do is we're going to put sample points down, right? That's sort of what we were doing, is putting down these sample points, right? And I believe right now we're doing that, I think, in a fairly structural way, like this sort of thing. But there's really no reason for that. We could perturb them and make them random. Our algorithm doesn't depend on the placement of these things, but it is the kind of thing that we haven't investigated yet. So we're really, I think, doing a regular sampling on there at the moment. Correct me if I'm wrong on that. I don't remember where we stopped with our experimentation, but... So when we send one of these things down, we're typically collecting lighting information on the actual surfaces that are bouncing around. And then what we're doing is we're saying for each one of these, we treat this sort of plate effectively as like a collector. So that we're going to send rays out from it, and we're going to see what they hit, and when they hit something, which itself is going to be another one of these things, right? We're going to send some of that light back. So we're going to basically collect that light by moving it back to sort of flavor this tile. And then when we go to render, what we'll do is whenever we're rendering a particular location, we'll just sample from the points that are on the surface that we're sampling, and we'll color that in, right? Now, this is actually exactly, like basically everything about what I just said is exactly the same as what a light probe really does do for any real definition of the term light probe. But there is one thing we did, which I think is probably a mistake. In our system that we didn't really consider changing, and again, the reason for it I'll go into in a second. It was mostly just because I didn't really think about how you would be able to overcome a particular limitation of the real-time nature of what we're doing. Because an important thing to understand is light probes traditionally are not dynamic. Traditionally in games, light probes are static. So a light probe is something that you pre-compute and you stick it's somewhere in the world. You do a real ray tracing on your world when you like bake the game. And what you end up doing is you just use those light probes at runtime without really ever updating them much. Right? And so they're not really a real-time construct, or at least they weren't. But turns out you can make them real-time, and that's really the reason I hadn't considered them. So anyway, let's talk about theirs for a second. So what were light probes? What's the difference between what we were doing, which is basically a light probe actually, and what theirs is? Well, the main difference is separation of, reflectors and collectors, is I guess the way I would say it. And the important thing to understand here is that we, even in our system, we do actually have totally separate conceptualizations for what is a reflector and what is a collector. We have points that collect information for our lighting, and our occluders, our reflectors, are these big cubes, right? And we do treat them separately, but they're always in the same place, right? So they're separate in our implementation, but they're not separate in terms of their actual spatial distribution. Our reflectors are always these rectangular solids, and our collectors are always on the face of them, and they're tightly coupled together, right? And that, I think, was our mistake. That, I think, that fundamental misunderstanding, or not misunderstanding, I guess, just fundamental bad decision that we never experimented our way out of, I think is why our lighting is not where it should be. So let's talk about what I mean by that. Let's say that instead we went with a more traditional light probe approach. What would that look like? Well, what it would look like is in the world, we've got sort of maybe a little dungeon area here, and we know that there's tons and tons and tons of these reflectors everywhere, right? It's tons of cubes all over the place, right? Well, we had to distribute collectors proportional to the number of reflectors. That means that even if the optimal lighting sampling for this area would just be to strew a few lighting sample points in this whole region and blend between them, we were instead massively oversampling these areas, right? Just taking tons and tons and tons and tons more samples than we needed to, okay? Now, maybe it would have been fine to drastically undersample those by placing a few strategic points and just collecting from there while still using the same number of reflectors. But we can't do that with our technique, because our technique always, just by default, the way that it worked was there isn't a separate notion of a collector that exists outside of a surface, right? And so that is really the key problem. And the reason I think it's the key problem is because it prevents us from placing our collectors in the most optimal, most minimal fashion, right? Because whatever you built as the world, you're locked to distributing your collectors in that dense, that arrangement. And it means even stupider crap, like we more or less don't even know whether we should place collectors on the bottom of a cube. Like we could go in there and start removing them from interior points, right? That would be one pass. But it's still just, it's not enough, right? And I think we almost sort of talked about this. I said when we build the world, one of the reasons we switched over to world building and didn't do any more experimentation with lighting was because I actually said even this statement. I said, yeah, we need to start having our world place these points more strategically, even for our own technique. And I think I was right. But where I was wrong was that we should have separated these things more dramatically than we did right from the start. All right? Okay. So in the theirs approach, what they actually do is they place collectors just evenly spaced kind of throughout the world in the interior regions. So for example, whereas ours would have taken, let's say, from a side view, whereas ours is placing the collectors kind of this sort of way, right? Theirs is placing the collectors like that, like in the interior. The other really good thing about that is you can see when we go to lighting sprites, you can see why that's more handy too, because the collectors are existing in places that are more central to where the sprites would be as well, so that they're not just always on the surfaces, which might not capture some of the things happening in the height. And furthermore, you could choose to get more fidelity by placing, say, more of these throughout the volume if you felt like you needed more collection, right? Okay. So why didn't I do that to begin with, right? Would be another question. And the reason is because I failed to understand a relatively obvious thing in hindsight, but when you're thinking through algorithms like this, it's pretty hard to know everything and really like understand it all if you've never already solved the problem, right? And again, this is not my field, right? I don't work on lighting. It's not something I do. So it was as new to me as it was to you. Well, possibly not as new. I mean, I had written ray tracers before and stuff like that. So the fundamental concept of moving light around maybe was not as new to me. But, you know, the computation, real-time computation of lighting inside a game is not something I ever worked on as a problem. And so it was completely new to me. And that's, again, one of the reasons why the understanding isn't necessarily there to just do the right thing right away. Okay. So the thing that I was getting hung up on was the real-time computation of it. So in my mind, I was like, well, if I actually place a collector here that's hanging out in the middle of nowhere, how do I actually compute its value in real time? Because the only way in my head, I was like, the only way I can really get lighting samples into this thing is I've got a light source somewhere, I've got to shoot a ray out from this thing, bounce it around a bunch of times, ray tracing style, and eventually get back to the light source. That's a nightmare. I'm like, that's going to take forever in real time. That's never going to converge frame to frame or even cross multiple frames. That's like a very expensive operation. Forget it. It's not going to work, right? So I was like, oh, our collectors and our reflectors have to be the same surface so that we can sort of do a more radiosity thing where light sticks to things every frame and then gets re-radiated out, right? Gotta do it. That's in my head. You know what I'm saying? But actually, there's a really simple, obvious answer as to why you don't have to do this that I just didn't consider. And what that is it's just like, use the probes during casting. Now, I don't know why I didn't think about this. I think it's just because in my head, for some reason, I was like thinking that you can only use probes for real-time lighting and not for the ray casting stage. But don't do that. Just use the probes all the time. That way, you just send out one probe cast. you take the point that you hit, and then you do the actual summation using the existing light probe state to figure out what that lighting value should be. That's all you actually have to do, right? And so that allows you to do the exact same thing I was doing, which is having all of the surfaces have an incremental state that you can sample. You just do the same thing you'd do during your real-time lighting, right? Very, 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 very simple, and I don't know why I never thought of it. I literally never thought of it because the only reason I thought of this time is I recently saw a paper in the Journal of Graphics Tools called, blah, 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 and something, indirect light computation, real-time something, right? And I was like, they're doing real-time ray tracing of light probes in this paper. And I'm like, let me go read the paper and see what they did for this problem. Because I'm like, this is the thing that's like stuck in my head as to why I didn't use light probes. I'm like, I don't know what to do. And I just get to that part of the paper expecting something important. And they're just like, during computation, when we hit a surface, we just use the existing light probes from the previous frame to compute the lighting. And I'm like, oh, God. Like, why didn't I think of that, right? And again, it's just like, brains aren't as logical as you think they are, right? A lot of times it's just like you're randomly trying to think of ideas, and sometimes you hit upon the right one and it's very simple, and you think, I'm so stupid, why didn't I think about that? But it's like, that's just not brains, right? It's just not brains. And that's why reading papers is so useful, right? Because there's so many more people trying so many more things. Someone's going to figure out the answer if it's out there, but it's not necessarily going to be you. So read the paper, right? And so we really don't need to know anything else. Like, that paper is it's a good paper, actually. It's mostly more about GPU tracing of light probes. But it has the answer we actually wanted, and it's not even a thing they actually cared about. I think it's something that I could have really read probably previous papers and figured it out, right? But it's like, this is just the one I happened to see. I was like, I should go see what they do, because, like, obviously they know something I don't. But it's like, barely, right? It's like, it's something I should have thought of. So, oh well, life goes on. You can't win them all. But given that is so simple to do, I think that makes it sort of overwhelmingly a good idea to sort of move just very slightly, I mean, basically not that big of a change, over to their system, because that would allow us a tremendous amount of opportunity for speed increases in two ways. One, it simplifies the description of our collectors, so we could get rid of that expensive stuff we're doing about seeing like which one of the points should get which amount of return and stuff like that. So we can switch our collectors to a more standard, just straightforward like cube collector kind of a model or something, right? And not have to have like these like sub points on the cube and garbage like that. So that's great. And it also then allows us the really great sort of fringe benefit of letting us have our collectors be spaced as arbitrarily as we want throughout our volume without them having to have any particular correlation to the rest of the scene. They can be placed via any algorithm we want, and they can be completely decorrelated, and so that we can basically just fine-tune that as like a separate lever, if that makes sense, right? All right. So again, just a small little mental block there, and I think there's potentially a lot that's unlocked by just realizing, just sample the light probes when you're casting. And that just gives me a huge tool I just didn't have, right? All right. So that's all I really want to do. But there's a lot of complexity in there that we need to start addressing. So there's going to be a lot of code, and it's going to be several weekends. So don't fool yourself. It ain't going to be quick. And the reason for that is there's just a lot of additional things that we're going to have to work out as we go. And one of those things, I would argue probably the most important thing, is one that, again, we probably want to go read some papers on after the fact to probably get something that's going to be a little bit better than what we do, because what we do is not going to be as good as the whole graphics community working on this problem. There's a lot of good people doing a lot of this stuff, and so they're going to come up with better things. But I would like us to try it in Handmade Hero fashion. I always think we should try it ourselves first, because that's part of the learning process. You want to learn how to do things yourself as well as learn how to take information from other people and implement it. And so we always want to try things first and then follow it up with a look, even though in the real world we might say, like, we know we're not going to come up with the best thing, so we'll just go read it, right? That's a difference between an educational stream and a stream where we're just trying to be as efficient as possible with how long it takes us to implement the best possible thing. And so specifically the part that I think that's new, and we would have had to do this anyway for our sprites, so it's not really a big deal that we're having to do it, because we would have had to do it either way, but we now have to do it right now. It can't be delayed, because even if we don't light our sprites, we're still going to have to do it. That is, given a set of light probes in the world, we have to figure out which light probes we use for any given pixel on the screen, or if we want any given object, etc., etc. We need to figure out which light probes to sample, because there could be up to 8 if we wanted to. If you imagine these light probes being strewn, and we wanted to separate into a volume. Let me grab my tablet back here for a second. So if we were to, for example, say be in a situation where we had light probes in a volumetric pattern like this, right? And we want to sample something, the lighting in here, we might, depending on what our speeds profile looks like, and maybe graphics card settings, who knows, we might want to go so far as to sample from like 8 probes, right? And do a cubic, so a trilinear interpolation to figure out what the lighting should be at that point. Now, we may want to mostly just do 4, because since we're a mostly planar game, we can probably optimize it and only really look at things like a trilinear sample when we're maybe going up and down stairs. We could do optimizations like that. So we might want to stay with with 4 probes most of the time, but either way, no matter how many we do, it's at least 4, could be as many as 8. We're going to want to take those samples, and we need some way of figuring out which ones to sample, because all we'll have, especially if we allow a relatively arbitrary placement of these, all we're going to have is just a giant one-dimensional array of probes. I mean, that's it, right? And so that's really the thing that we've got to deal with here, and I don't really know how, right? I didn't read that part. I haven't looked at how people are doing that, because I wanted to think about it and do it ourselves on the stream. And then we can just correct ourselves and see like what's better than what we did, right? But that's the main problem, because everything else about this scheme is something that we already implemented, and we're just going to tweak a little, more or less, right? We're just going to change our algorithm to separate the collection and reflection phases, or descriptors. That's really all we're going to do. And then we're pretty much good to go. So at the moment anyway, we don't have much to do to get to to a more traditional light probe model. But this part is completely new. We don't have a way of doing this. And if you think about it, it's relatively tricky because, you know, the naive approaches would just be probably bad in both ways. So, you know, naive approach 1. The naive approach to this would be 1, like some kind of a grid. You know what I mean? So basically, like, you just got this grid lookup, and so you've got to space these things in a particularly regular way. And the reason that's is like it's too many, you know, probes in the wrong places, right? So if we just strewed probes through the world in a regular pattern, well, the lookup becomes trivial, but it's not putting probes where we want them. So we would much rather have a way of placing the probes in a pattern that's more amenable and allows us to place them flexibly to concentrate them in areas we want and not in areas we don't, right? So, you know, that doesn't necessarily mean it's out. It just means it's kind of questionable, right? 2 would just be like linear search, right? And that's just not going to cut it either, because that would have the graphics card or somebody plowing through on a pixel by pixel basis if we wanted to do per pixel lookup or sampling. Heaven help us. That would imply some really nasty sampling of like, you know, potentially like 1,000 of these things, you know, that we're looping through every time. And that's obviously unacceptable per pixel. Now, whether it would be acceptable in some non-per pixel way, so like we look it up, you know, per element or something, and so an entire element just loads into the constant store the 8 light probes to sample, and then it renders the thing. Yeah, okay, you know, then something really naive might just work. You know, we're burning some cycles we don't need to burn there, but it would work. And furthermore, it would become not particularly bad because we could use a spatial partition, right? To speed that up really trivially, because if it's only happening once per element, the spatial partition doesn't even have to be good. It could just be real basic. You could chop that down to like 20 or 30 and then linear search and it would be fine, right? So, you know, that method seems like, I guess what I would say is, it seems totally doable, even though it's naive. It just may not give us as good a lighting quality as it could, because we can't transition from one probe set to another probe set for things that straddle the probe boundaries. So, for example, if we have a relatively large sprite that's sitting, you know, kind of like that, what we would like is for it to switch as it crosses this plane. We'd like it to switch to starting to use these probes as it moves across, in much the same way that we would bilinearly filter a texel. As we move across the texel boundary, we want to switch to sampling from the next set of texels over. We would want to do the same thing here. And so the problem with these is this creates a burden on our world placement and management, and probably on our lighting as well, because there's too many probes being placed, and so it's not optimal. This means like no per pixel, right? So this is like bad placement, potentially too many. This is no per pixel, right? You know, we could definitely do something naive if it wasn't per pixel, but if we wanted to do something per pixel, forget it. It's not going to happen, right? So that leaves us with the question, okay, let's analyze our situation here and figure out if there's something we could do, you know, some way we could get ourselves to a point where per pixel at least seems plausible, meaning we could make an argument that we wanted to sample per pixel the lighting, and so, you know, GPUs are very fast nowadays. There's some lookup work we could do. Certainly scheme 1 could be per pixel, right? I mean, if you think about, there's a reason I wrote this on this one only. If it was something as simple as just look at the world coordinates of this pixel and, convert to the 8 cells and look those up directly in a 3D texture to get yourself a probe, or whatever. No problem, right? So we know that there are things simple enough that a reasonably fast graphics card could definitely do them per pixel. And the question is just, can we make a scheme that isn't as naive as just a grid lookup, so that we can get the benefits of something that has good placement, but that doesn't actually require you to use some really complicated lookup that's going to be too pricey, right? And the answer there is, I don't know. The answer is there, I'm not sure, right? If we look at the back of the envelope calculations on stuff like that, we've done some of these, before. If we looked at having some kind of a voxel, 256 by 226 by 226. If we looked at having some kind of a voxel lookup texture on the card that we update periodically, it's not the end of the world, right? A 64 megabyte texture, which would be, and in fact we don't really need that. It'd probably be a 32, because we would only need a 16-bit index, So if we had to, right, looking at our lighting transfer information, it wouldn't be the end of the world to send down a 32 megabyte texture every frame that was the lighting locations. And furthermore, if we needed to compress that further, we could actually generate that texture ourselves, probably, on the GPU directly using a more efficient list. So, for example, if we wanted to, we could probably send down just a linear array of our light probe locations, and then we could have the GPU spam those light probe indices using the location by rasterizing a single primitive per light probe location, thus creating a voxel fill, right? So we could, if we want to, even use the GPU itself to voxelize for us, which would allow us to send down a more compressed representation if that 32 megabytes was proving onerous to transfer for some reason, which it probably shouldn't. I mean, the bandwidth to the graphics card's pretty good, but you don't want to stress it out too much for obvious reasons. So, I do think a direct lookup isn't out of the question, because what we could do is, rather than trying to pack all of the information into an actual voxel, which I think might be too expensive for us to do, what we could do is just pack our lookup, the minimal amount of information necessary to look up into some other structure, into the voxel, and maybe that would be sufficient. And I suppose now that I'm thinking about it a little bit more sort of a little bit more directly, it does seem like that would be pretty easy to do. You know, we already had a scheme in here earlier on where we looked up lighting in a voxel pattern, right? So it's not really something far-fetched. One of the problems that we'll definitely have is just, you know, figuring out how that voxel is partitioned in a line to make sure that we get good use out of it. But as long as we create, you know, I mean, if you look at the world as it stands, we probably wouldn't need to place sample points. Like, inside a given volume here, the lighting fidelity is not supposed to be particularly good. It's just supposed to give a reasonable approximation to the lighting. So if we think about it, it probably isn't particularly difficult to imagine the lighting just being no more dense, say, than inside one of these tile regions, like a normal room region here. You know, we wouldn't have more than 8 light samples in the densest case. You know what I'm saying? And if that were so, we can see pretty clearly 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, how many? And let's zoom out. Let's get the biggest possible view here that we can. And so we look here. What do we got? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, maybe. So figure something. Let's just say something like 60 across. And so even a 128 voxel that was screen oriented, right? Would have more than enough fidelity to record the amount of lighting we would really require. And Nyquist-wise, if we bump that up to 256, which is the calculation I just did, we're more than covered. Depth-wise, I don't know, but I would say probably the same thing. 60 deep tiles, I mean, we're not trying to have that much field of view here, so that should be more than enough as well. So I would think that if we use sort of like a screen space kind of voxel, and if we wanted to, you know, we could just, like I said, rasterize that in the GPU every frame even. So just using a light probe list that we already were sending down, I think we've got a good shot at that. So my assumption is that maybe voxel lookup, because we know that a graphics card can do that really easily. You know what I'm saying? Take this method and combine it with this method. So we're just basically saying use a voxel, and into the voxel just write the closest light probe to that voxel. Right? I think that might be good enough. You know what I'm saying? And so let's just try it. Let's just try that. And what we can do for starters, right, is we can draw all of this stuff, mostly CPU side, really slowly, and just get it working in an environment where we can debug it. And then, when we're sure that everything's working within a reasonable degree of satisfaction, at that point, we start moving these things to the GPU one by one. And we can still leave lighting CPU, calculation CPU side, using the exact same techniques that we're using right now. And I think that would probably do it, right? So I hope that gives us what we need. All right, so let's start down there. We're not going to get very far today. We don't have a whole lot of time. What do we got, an hour and a half maybe? No, just an hour, I think. So we're not going to get very far today, but like I said, it's going to be a multi-weekend project. That's fine. Lighting is very complicated. It's probably the hardest thing there is to do in graphics. And so, you know, to be expected. Loading up Handmade Hero. Just going to do a quick build here. Make sure everything's up to date and correct. Looks like it. So I'm going to go ahead and open up our lighting routines here and just start to kind of get a little bit more. I'm going to sort of work towards there slowly. So I think the first thing I want to do is I'm just going to more or less like turn off lighting in the actual game. And I'm going to focus on creating the lighting probes themselves as the important part of the problem. And I'm going to ignore the gather for a little bit because we need to sort of take it one step at a time. So if I go to the OpenGL renderer first, and we start to pull out, like I'm going to go to the ZBias program. If we start to pull out the part where we're actually sampling things, here you can see our fragment code. And the way this is working, you can see the fetch and sum here where it's summing up the lighting. What I'm going to do here is I'm just going to have this stop doing that operation. So rather than sampling from these pieces of light information that we had, I'm actually not going to do that sampling. And we're going to revisit that later when we're ready to go, right? So this lighting disabled part of things, that I'm just going to turn that on. And we're going to just require that the lighting be disabled all the time as we go. So in here, where are we here? Here we go, lighting disabled. So I'm just going to hard code that now. So lighting disabled is always off in our shader. It's never going to do that summation. And so when I run the game, we should now see that everything is always full bright everywhere, right? So we are computing the lighting still so that I'm not actually setting lighting disabled to true because the rest of the lighting is actually running, and you can see that here, compute light propagation still doing its thing. But while we're at it, we're going to turn that display off so that it's not interfering with our ability to visualize what the world is actually looking like from time to time as we send down like colors for things, which will help us potentially debug stuff, right? So the next thing I want to do is I want to introduce a special entity type into our system that we can use to do light probing. And this entity would just be literally a light probe entity. So as we kind of walk around in the world, I want to be able to draw out, like I want the room generation code, right? To be spamming down some light probes that we can use for light sampling. And at first we can do that in a pretty haphazard fashion. We can even just spam them. Every tile that doesn't have a wall on it can have our light samples in it. And we can just go from there. Now, one of the things that we don't have right now, and I don't know why, I thought we had it a while back, but we don't actually seem to. You can look here, and even if I expand everything out, I'm not seeing it. In the lighting, we used to have a way of displaying, like, and it's, yeah, just, I don't know where it went. We used to have a way of displaying some statistics, and those statistics are pretty important. I would like to see lighting information displayed here, and it's not. So I'm going to try and go in and get some of that back because as we create this sort of new pass on the system, I really want to have some way of making sure that we can measure it as we go. Like, I don't want to be completely flying blind here. I don't want to not know how many samplers I have, how many collectors I have versus reflectors. We had that information. At some point, we got rid of it, and I want it back, right? Okay. So here in the lighting system, somewhere we're pushing some information, and we're just not pushing that particular piece of information. I don't know why. So here you can see, for example, we've got debug values, total casts initiated, total partitions tested. All of this crap is stuff we want, and I'm not seeing it. So that's what we want to do. And I think the main reason is because we kind of got rid of, right when in there we're not opening up the lighting bracket as a thing that we should be sort of storing it as. So I'm going to go ahead and look for that particular debug output just to see where it actually is. So let's see here. That is not what I'm talking about. Where is it? Here it is. So you can see here we've got some nonsense about the debug lighting block with, you know, this sort of stuff here. And this is what I want, but it's not where I want it, might be the right way to put it. So what I'd rather do, and I don't actually know if this is the right way to do it, but it seems like good enough at the moment, is I'm just going to stuff this in here, and I'm going to like display my lighting information as part of this system, right? So where we were doing this stuff here, I'm just going to go ahead and open that up, and I'm going to put that in here, right, like so. And I'm going to start building up like what we're printing out in terms of that information. I think that part right there should just work probably, and now we should be getting those stats, but there's some other stats I'll go gather up as well, just so we can output those into the lighting. Okay. So there you can see more what I was looking for. Right now we've got like how many times were we casting rays, how many partitions of our sort of octree, well, it's not an octree, it's more like a bounding volume hierarchy, of our BVH. What are we testing here? How many partitions per cast are we visiting? How many leaves? How many partitions per leaf? All that kind of stuff, right? So, you know, essentially what we're looking at here is, well, we can probably speed up this stuff because it's going to be a little simpler than it was before. But really what we're trying to do here is maybe get this number down, right? So total casts initiated, we would like to get that number down at least by maybe a factor of 2, so that we, and really where that's going to come from largely is reducing the number of samplers that we actually have to cast. Hopefully. That's what we're trying to do anyway. So again, just want to collect that data so I can make sure that we actually are reducing the number and not increasing the number. So I'm going to go through here and just see, I don't know where else we have a debug value out. I may already have that number. I'm not sure. So yeah, you can see light box counts. Like this is what I'm actually looking for here. I don't know if I can just add those over there so we can have it all in one place. That would be nice. I'm not sure if we can or can't, but I'm going to try. And just see if I stick that in here. So do we know this information at this point? I'm not sure. Here we do. Oh, we don't. We don't have the group. We don't have this. So we need that group there. Compute light propagation. Where does the group come from? It's just the render group there. And that information doesn't actually look like it's, yeah, it's coming. So, I guess I'll just get rid of that. I don't know, we may have that in the lighting solution anyway. Yeah, so box count is that, right? So I think we don't really need that. So I think we're okay. Seems reasonable. All right, so let's take a look at what numbers we're actually seeing here. So if I look at my lighting, you can see here what the numbers are that we're actually pushing through the system. So we've got 445 boxes, I guess, that are coming into the system via the lighting volume here. And again, that lighting volume is not all of this, right? It was just the visible region. So 445 boxes, if we looked at how many there would actually maybe be in this area, that comes out to 6097 points. I mean, I don't really know, but just eyeballing it, getting that number down should not be hard. If each one of our lighting samples, and I think we can get away with fairly few, maybe just 2 per tile, possibly even just 1 per tile, but 2 per tile maybe. If we got down to like 2 per tile roughly, I mean, I think, let's say we got it down to like 2 per tile, which I don't think would be too bad. If we got it down to like 2 per tile, then I think we're looking at something more like 3,000 points maybe, which is, you know, cutting that in half. Because we still have to sample in each of the directions. Although, actually, if we treat each one as a single point, we may be able to get down even further, because they're not really points anymore. They're sort of omnidirectional. So when we can cast in arbitrary directions, and for each cast, we just know which sort of lighting direction it contributes to. Yeah. Yeah, all right. So I think this should be pretty reasonable. So if we look at our lighting solution, at the moment, really this is the part that's going to change. So this point count, extended point count, points, initial PPS, emission PPS, this is the stuff that really has to be changing. Now, for our immediate purposes, what we should probably be able to do here is do the minimal amount of change by making our lighting points now come from individual light sample volumes, and those sample volumes would have exactly 1 point on each of the 6 faces of the cube in question, right? So let's start down that road. The first thing I would need to do is I need to start placing these things in the first place, right? And so, you know, we're going to have something where we can place one of these things down so that entities can have like a brain type of sampler or something, right? However, I don't really know if I want to quite do it that way. And the reason is because our lighting sampling is really pretty sensitive to where you are in the environment, how you would move around. If we had a tile that was moving up and down, right, we would probably, like, that was kind of floating, we would probably want the sample points to float with it. And the reason that I say that is because otherwise, if it floated up too high, it might itself occlude that sample point by, like, entirely encompassing it, right? Now, what we could do is say that encompassing a sampling point is fine, because you're not really going to block that sample point from shooting rays out. Is that true? If we allow you to shoot out of a volume, then I guess that's fine. So I guess we can just do it this way, right? So if I said, okay, there's a type of brain that's just called a light probe, right? And I place it in the world, and that's the end of it. You know what I'm saying? I don't know. Maybe that will just work. And I can add those to the world right now. So what I would do there is when we're in the room gen code, you can see here we've got 2 things. One is like generate apron. That puts down tiles. And then the other is generate room. And that puts down tiles. I can just place light probes and off we go. Plus, I can be even a little bit more squirrely about it and say, well, actually, when I'm doing this room generation, I could place light probes more densely in areas where you actually go, and then when like I'm generating the apron, I can place them much more sparsely, because maybe we don't care if the lighting out there is particularly good, right? Because we know it's just sort of like ambient nonsense that's not really the focus of your attention, you know? So that seems pretty good too. So let's start by just placing probes that are in rooms so that we don't place them in the apron anyway. And we'll go from there. So in here where we place like, where we actually put things down, I think all I'm really gonna check is whether or not something is a wall. And I'm just gonna say like I don't wanna bother like putting probes on walls yet. We may need to do that for collective, we may need to collect data on the, like up maybe above the walls or whatever. We may need to do some of that. So this is not a final thing. But I would like to sort of say, this wall height bit, I want to know whether I'm on a wall or not. And if I'm not, then I place one of those things down. So maybe I say like, okay, the traversable here, there's also a like, on wall equals false, on wall equals true. And so then down at the bottom here, in fact, this can also sort of be done this way. So then finally, when I get to the end, you know, and everything's sort of been done, I can just say, all right, if I was on a wall, maybe I'm going to add an entity here. And that entity is a light probe. And the place that I'm going to add it is just sort of in like the center point of this thing. And when I say, should I add one, should I add two? I don't really know. What I'm really considering there is, should I have like one low one and one high one so that we collect different lighting information that we can use to sort of see what's the difference between high and low. I kind of have a sense that maybe we do want to do that. And so, you know, maybe I'll really do that. This should be not, by the way. So I maybe want to add 2 light probes and one high probe, 1 low probe. And I want to add those in locations that make sense based on the positioning that I see here. So what I'm going to do is say that those light probes are going to be added at a certain understanding of the base entity P. I would like to sort of take that and say the sort of the basis P for this thing is before I've done any of this kind of like weird offsetting of it, like the random unilateral parts of this, for example. And I'm going to use that as sort of my basis, right? So I want to add these at the basis P, but I want to offset them by different amounts here. Largely just Z differences, where I'm going to add these light probes. I think that's really all I need to do. I'm going to pass the generator down here as something I use when I'm adding the light probes. But other than that, I think we're good. And so when I add this in, what I want to do is I want one of the light probes to be low and one of the light probes to be high. The low light probe, you know, is going to be, you know, I don't know what these numbers should really be. I'm not sure, but we'll tune them in a second. Whatever they should be, you know, they're going to look something like that, right? So there's one that's like high and one that's low. You know what I mean? So we'll look at where they get placed and we'll figure out, we can even make them proportional to the height, to the floor height as well. Other things like that as we go. But anyway, in fact, let me just add that in there as well. So we'll basically take however high, you know, the Z height is of these things, and we'll multiply that out, right? So I don't know, something like this. I'm not really sure. But this is just to spam these entities into the system so that we, have a way of setting up an initial sampling that we can then use for our lighting. And at first, it's not going to do anything, right? It's going to be completely useless. But then as we go, it'll be more useful. All right. So in here, we've got... Where's our... Oh, I don't want that file. I want an entity gen. I'm like, where's all our entity generation? So here we go. If I want to add one of these saucy gentlemen, right? I just am saying here's the position of our light probe. I'm going to add that in, like so. I'm going to set its brain ID to the special brain ID for light probes. I don't remember what type brain light probe. And honestly, I don't think there's anything else we actually need. It's just the position and the ID, and that's it, I think, at the moment. So that's going to add a bunch of these light probes to the scene. In theory, that should just work, but of course, we won't actually be able to see any of them, right? Do I actually need this? Oh, this is totally wrong. Probably want it that way. Is this redundant? No, it's not. All right. So that's really all I wanted to do. And I'm going to have to go past that region down. There we go. I guess this is... So I guess when I'm looking at this too, the brain slot thing... So when we had a sort of... That's right, because brains are sort of allocated on an as-needed basis. And we don't really need to allocate anything for this particular brain. So when we actually look at this, what we wanted to do here is say that this is a special brain slot, not a brain ID. And then I think we're good to go there. Okay. So this needs to take the region. These need to pass the region down. And then I think we've added the light probes to the system, and that's a good thing. But we wouldn't see them. So if I run now, they don't draw. So, they're effectively not there, right? So what I need to do now is have some way to visualize those things. And so inside the world mode, I'll probably go ahead and have a global here for rendering that stuff. If we look inside our lighting, we sort of already had this stuff like show reflectors, show visibility, that stuff. So if we hop out to the globals here, which is, that's not what I'm looking for. Here we go. So if we look at this stuff, this is what I would probably want to modify our global controls for this sort of thing. Why I haven't used these at all, I don't know. We added them in there and just haven't really done much of them. So I don't actually even know if anyone's using these right now. I think they're probably old news at this point. Yeah. So really what I want to do is change those into something we actually care about now. So this global renderer lighting show reflectors nonsense. And I don't even really need it to do that because, we don't need to name it anything weird like that either. Because as you can see, when you put it in the lighting system now, it just shows up normally. We didn't do the underscore parsing nonsense that we sort of had suggested we would do. Well, we did it, but we don't need it. So what I'd rather do here is just say, let's make this a little bit more, a little bit easier to understand. So maybe this can just be called global lighting. And then here I'd do like show probes, something like that. And this way we have some understanding of whether or not it's going to be happening, but we can also always like turn it on and off. And so if I go into the world mode here, you can see where that stuff is, you know, being ifed upon. Actually, I don't really remember. I thought we had done some weird nonsense with pound defines for these as well, but I guess we switched to not doing that anymore. I don't know. Too many things in Handmade Hero. Anyway, so if I take a look at what's going on in the rest of the code here, you can kind of see where we do some ifs on these sorts of things. What I would like to do is, before we, you know, finish rendering the world, if someone asked us, right, so if we had like, you know, global lighting show probes, I want to loop over the probes in the world and draw them. Now, it occurs to me that since we're already looping over entities anyway, maybe really what I want to do is inside the entity system, while we're drawing the stuff, say, oh, is this a, you know, is this one of those, right? So when we're doing stuff like drawing traversables or drawing who knows what, if we're in global lighting show probes mode and this entity happens to be one of those special ones, which I don't actually remember how we like to test for that. I guess it's just brain stuff. Okay. So if we just create something here that's like is light probe, and we test it the same way we were testing before, then what we can do is say, well, special case these guys, when we see them come down the pipe, we'll push a little cube on there right now that just lets us know they're there. And later we're going to want to do something better than this, because we're going to want to actually show what the lighting is. But otherwise, you know, we should be good to go. And in here, I don't really want to do anything special other than use the exact entity P so that we don't get confused about where this thing actually is, right? I also have no idea what that 3.0 is, but it's probably the radius of our cube. Let's see if that's true. No, I am incorrect. The first parameter with the V3 there is, so that's the lighting store and the Z bias. All right, well, that's fine. So anyway, point being, pretty simple, just gonna push this thing on there, and we'll see if we can see anything show up. So if I go ahead and run now, here's the debug display. We can see all the cubes. I guess what I would say is the low ones look pretty good. The high ones look way too high. Other than that, no problem. So I think what we want for high gather there is maybe like not so aggressive. If we take a look at this, maybe we knock that down to just like a 0.5, or maybe we knock it down even further than that. Because we really want fairly low samples in both cases. We just want a little distribution so we can see the difference. So that seems a little bit better to me, right? So I think that's good. Let me hop out to an area that actually has also, the Z bias looks like it's causing a problem there. I don't know why I closed the game. Let's turn that off. So there's all of our saucy gentlemen. If I hop along out to an area that actually has some rooms stacked on top of each other, I could get a sense for like what's getting probed there, which would be good. So I'm just gonna go down to the stairs and take a look. So here's the stairs, and I'm gonna kind of just take a look at where those are getting added. So that seems good, but you can kind of see, because of the stairs, we're going to probably want to fix that so that the stairs have the sampling placed more strategically on them. So that part needs to get updated there if you're a stairwell. I think that's the only thing we really need to modify. Let me go ahead and do that. It's probably pretty straightforward to just use the stairwell modification. So this here, I'm thinking maybe looks more like this, right? So that way we apply that before we look at the basis P for that thing. That would give our stairwells more of a... the lighting probes will follow the stairs down, because we don't really need... There's not going to be things like hovering up in the like higher area of the stairwell hardly at all, if ever. And so we don't really want the lighting to be primarily sampled in the areas where people aren't. We want them to be sampled primarily in the areas people are. And then if you're outside of the region where people are, well, then we'll interpolate and get a worse answer. But we want, like, most of the time where you're standing, where you're going to be standing most of the time is where we want the lighting to be sampled, right? That's just kind of an obvious statement. Okay, so if we look at how many lighting samples were like sort of spewing out into the world there, one of the things I would like to know at this point is how many entities... Suppose we actually just took all of the lighting that's in that entire gigantic region. How many entities would that be? Like, how many light probes are in the scene right now for every last thing that we saw there, right? So if we look in here and say for every entity... and I assume the active flag would stop anything when we iterate all entities. How is that actually working? Yeah, so that's iterating of the hash log, because that's only the things that are in the active sim region, not in the entity cache. So that's good. So when we go through here, what I want to do is just take a summation. And I'm just curious, like, how many light probes we've got, because I have no idea, right? So tell me how many light probes we have when we go through here, and off we go, right? Now, I'm going to go ahead and do this, even though I don't know if I actually want to do it this way in the end, but so that I can facilitate that summation, I'm going to go ahead and sum the light probes, even if we're not showing them, right? And then what I'm going to do is just output that piece of information. So inside the lighting, I've got this bit of sauce here. I'm just going to reopen that block, and I'm just going to dump that light probe count out here, right? So the light probe count now will just tell us like how many there are in the entire scene. Let's take a look at that. Okay, so just looking at that, hopefully that can give you an appreciation for just how much better this scheme probably can be. Even if we sample high and low, which we may not even really need to do, I don't know. But high and low on every interior square gives us only slightly more light probes than the total number of boxes in just the lighting solution region. So remember, I'm counting everything now in here, right? All of these interior points in the whole thing, not just that small rectangular section. And so that potentially right there is knocking things down to a really much more manageable number. So coming out into a place where we have a lot more on the table. So let's get to like a really much more dense, densely populated region if I can here, right? So getting up to a much more densely populated region, again, it's not even twice. And in terms of its comparison to the point count, if we multiplied this number by 6, one for each face of the cube, we are still going to be below, right? So even just that, we could, in less computation cost, we could do our whole sim region, the whole thing, we could do with these probes at 2 per tile. And if somehow we could manage to get it down to 1 per tile, which we might be able to do, I don't know, that might be unreasonable. Because it might not give a good... I don't know that we really... we probably can't. Let's just start with that. Because we need some gradation from low to high to give it some shading so you can see like the difference between those two things. So we kind of want to have 2, I think, regardless, and that's just the way it's going to go. But... you know what we also could do, though? We could also not sample it completely. Like, we could have our light probes be sort of longer and sample them in a way that, like, takes a gradation into account from high to low without actually having to do a completely new set of work. But who knows? Anyway, so when we look at that, right, that gives us a really good piece of information here that suggests this could be a pretty handy way for us to improve to improve our lighting just in terms of sheer count, right? Because now we could simulate for the same cost, less even cost, we could simulate the entire sim region's worth of lighting. So that's great. Right? Okay. So now let's think about this a little bit more. How much time do I have left? What have I got? 25 minutes? I'm not really sure what I can do in only 25 minutes that would be particularly productive. Because like sort of the next logical steps of this are going to be a little bit more fancy. So I guess one thing I could do is build the voxel. That's not too hard. And we could start to verify that building the voxel is plausible. Okay, so let's think about this. So if we actually, I guess the first question is, do we actually want to simulate the whole sim region or not? And the answer is probably not, right? We probably only want to simulate the parts of the sim region that we actually care about, that are actually in view. Again, just to keep that number a little bit more manageable. However, if we were gonna, I'm gonna maybe start with the whole sim region anyway, though, and then just shrink it down as we go as necessary. If we were going to do the entire sim region, I guess one question I have is, what is the voxel density necessary to keep the entire sim region in it without actually having any 2 light probes occupy the same voxel, right? So what's the size of a cube necessary to make sure that that never happens? And we sort of already know, I guess, in a sense, because our sizes are sort of based on that to begin with, I think. They're based on tiles. So if you take a look, where we form that sim region, yeah. Where do we form that sim region? So sim bounds is what we're using. And so we do 3 times the standard world the standard room dimension. The standard room dimension is set in the world mode, so I assume okay, here you go. So I don't actually know why we're not using any sense of the tile dim there. Again, just laziness or confusion. But if you assume it's 17 by 9, then you're talking about 3 times that much, right? So you're talking about 17 times 3 in this case, which is pretty darned low. Is that really the sim bounds? Let's take a look. How many across are we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 26, 27, 28, 29, 30, 31, 32. Seems reasonable. All right. So yeah, I mean, a 128 by 128 by 128 voxel would be like way more than enough, probably. All right. So let's suppose we wanted to create one of these. So in our lighting solution, the first thing that we're going to want to do for sampling purposes, we just have to create one of these voxels so that we can sample our lighting and say, look, at this particular location, what's the closest thing, right? And so inside our lighting.h, inside our solution here, we just have to have one of these, right? And this has to be whatever our voxel dimension for lighting is. So much like we have this lighting data width nonsense going on here, I would say, yeah, like as we solidify our lighting chart, this should go away. I do sort of agree that like some of this goes away, but we do actually need one thing here because this is going to be fixed. It's like our light lookup voxel dimension, right? And so whatever our light lookup voxel dimension is, honestly, 64 might even be acceptable here based on what it looks like we've got. So, you know, this is it looks like it's pretty straightforward, but anyway, so if we want to make a light lookup here where we just say, okay, we've got a light lookup voxel, it's a U16 that's like light index or spatial light index. And it's just a voxel like so. If we want to compute this spatial light index, we just need to, you know, create an empty one. We then go through and for every like one of these sample points that we have, we flood fill out its index into here, right? And that's really all we need to do. That's pretty straightforward. That's not too bad. But we do need some additional information. We need to know like the inverse index dimension. And we also need to know the corner. So this thing kind of needs to, you know, needs to have its understanding there. I also think we probably want to do something like this. And just put it in its own sort of space. That's also so I can name these a little bit more clearly. Something like this. And then you're not going to get confused if there's other things that might be similar there. Right? And then I can just put this in there. Or maybe just call this the spatial probe index, something like that. And so I think that's all we would need for that. And assuming I name it correctly. I think what I can now do, if I have enough time, is just sketch out the routine that would take all of our actual probes and splat them in here as necessary, right? Now we can't actually do that because we're not getting light probes specifically. We're getting lighting points, which is not really what we want. And so we want to go ahead and actually have some understanding of probes specifically. So instead of point count, this is going to be probe count, not point count. Also, I don't really know what extended point count is. That's just so we can build light looks up, like hierarchical light looks up, so that when you do a cast, you can hit larger regions. So I don't really know if that's something we're going to want to do, but it might be. And if it was, we would probably do it using this spatial index. So what we'd probably do is actually build filtered versions of these, right? So we would have like each, our light probe would kind of, our light probe index would have like a 128, 128, 128 version and a 64, 64, 64, 32, 32, 32, 16, 16, 16, right? And we would have to like sort of filter these up as we go. I don't know if we're really going to have to do that, but we might. And so I do think that that's, I don't know, something that we're going to have to do, right? I guess that's remains to be seen. But we'll start out assuming, well, you know what I could do? There is one good way I could start out assuming that that we are going to have to do that. And that is inside the light probe spatial index, I could record the power of 2 or something, or in the count. Right? So we could we could do this in a way that would allow us to make these flexibly sized. You know, we could do something like this. So we could do something like that. I'm not sure. That might be kind of a waste of computing resources if it turned out we never needed one, but I suppose we could always just do that as an optimization later. So maybe in our first pass we will actually have something like this. Seems reasonable. All right. So let's suppose that we had our spatial probe index here, and we're not gonna actually do the sort of subsampling stuff yet, but we will consider it later. What we would need is some way of creating this thing. So we need something that's sort of like, you know, add probe to spatial index. And that's going to take something pretty straightforward, right? It would be the index in question that we're adding, right? So here's our spatial index. It would take the probe's light, you know, where in the world it's supposed to be. So basically the infinitesimal point that the light probe exists at. And then it would need one more thing, which is like the radius that you want to use to kind of splat it down. And, you know, that's the kind of thing that we can sort of adjust conservatively. And it, you know, we could probably actually solve directly for it by saying what the minimum light spacing is. But effectively what's going on here, right, is we need every cell in this voxel that anyone's ever going to sample to return an actual answer, right? So leaving a cell empty means that anything that is in that area will just be unlit. Because when it looks up into there and says what, you know, what's the lighting contribution here, there's no probe. So what we want to make sure is that we don't get into an undersampling scenario. Let me just draw this out really quickly. Because like I said, we don't really have much to do that can fit in the time left anyway, so I might as well do a more complete explanation. So when we're actually rasterizing these, let's suppose that our grid is too fine. So here's the voxel, right? This is our spatial index. But the world generator like only put probes like here, 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 and here, right? What we want to have happen is when somebody in this region queries what's supposed to happen, we want them to get, oh, you know what? This actually brings up a problem that we're going to have with sampling. Because what we want you to get is we want you to be able to figure out what these closest ones are. But actually, if we only point to one of them, that wouldn't be sufficient, would it? Right? I mean, it would be so long as that index also stores what the other closest things were to it, right? So, you know, if this thing always stores kind of like that bit of information, then I suppose it does. All right, that's fine. So in here, what we need to do is we need to store at least how to get to one of these things. And we can always say that if you get to one of them, there's some way to get to the rest of them, right? But you need to be able to get to one of them. And if you got to get to one of them, then the problem that we have here is that if there's grid cells with nothing in them, simply rasterizing the light probes or filling the light probes into the voxel for the cell in which they exist isn't enough. We need to fill them into all the neighboring cells as well that wouldn't have another light probe that was closer. So what we need to be able to do here fundamentally is say for any spatial location that you look up, we need the light probes to conservatively have filled so that there isn't any dead zone between two light probes where you think there's nothing, but actually you should have been sampling from some of them, right? So that's the thing that we need to prevent. And in order to do that, we need to enlarge the region we fill by a substantial amount potentially, right? So what we're going to do instead is basically like, you know, work this whole thing. In fact, maybe we just have you pass in effectively a rectangle P, right? That's like the probe min P, the probe max P, we fill that whole area for you. You know what I'm saying? So that seems like a good thing. Do we have a V3S? We don't. We have a V3U, but we don't have a V... We have a V2U, but not a V3U. We've got this one. That's sort of different. We probably should just standardize this one and make this Gen V3 a V3U, because that's effectively what it does. Like if you look at these are actually things we want. You know what I mean? Like we want all these. So in a sense, we may want to promote these Gen V3, Gen Volume, that kind of stuff. We may want to promote those to first-class math citizens now because I think other people can use them, like this code in particular, right? So I'm just going to sketch this routine out inside an if0 block, and then we'll worry about it tomorrow, starting in on it. But effectively what we want to do here is something along this lines. You know, min index, max index, right? So we want map into grid. And then what we want to do is loop over this entire set of things, right? So we want to then do lookups into our system, something like this. Right. So we're going to do some kind of a loop over each of the elements of this thing. And we want to loop each time through. I guess this part doesn't really make a whole lot of sense, does it? But each time through here, we want to reinitialize the y. And each time through here, we want to reinitialize the z. So if you look at what's going on there, I probably do want to just do this. I can't really put a declaration in there, though. Darn you, for loop. I guess I could just do it and then bind the value. Maybe we'll do it that way. So if I just do it, you know, the old-fashioned way, then we're just looking at a straightforward loop over all this stuff. And this is just flood filling that entire, well, flood fill is the wrong word. It's block filling, rectangle filling, right? That entire region. So the min p and the max p here, we're going to work over those. I'm going to fill the whole region. And what I want to do is I want to say, let's look up which light is in there, right? So I want to do like, find out what light is in there to begin with. And then like, if we're the more appropriate lookup, use us instead of it, right? So that's the two things I want to do. So first I got to get the spatial index, right? I gotta like get the sort of get corner light index or something, whatever we're gonna call that. So when we ask for the spatial partition, what's actually going on there, it's going to return us a pointer to the cell in question. And I'm going to pass it, you know, the X, Y, Z. So it'd be like that sort of thing. And then when we actually look at what that is, we could say, look, if the existing index equals 0, then we definitely want to use us instead. I guess I didn't actually pass that here. So the existing, if there's nothing in there, then it should be us. Otherwise, we're going to have to look up that particular light. And so we're going to have something like this. Whatever the existing index is. Like that. And if, you know, we don't actually know what the equation is going to be here, but if we're more appropriate, then we would still do it. Right? And so what we need to then think about is what is the actual algorithm that we're going to use to determine who is the most appropriate light index. And the answer there is just, I think, whichever the minimum corner is. Because, if, again, when you look at what's happening in this diagram, where we say, okay, you know, the worst case scenario for this algorithm is we've got 8 probes, and we want to sample all 8 probes, right? So if we imagine we've got a coordinate system here, x, y, z, then what we want to effectively do is give you back this index if you're anywhere in the cube, I think, right? And then from this index, it needs to tell you what the other 8 are, if you will, right? So effectively, you're getting an index to sort of a block, a sampling block, that tells you everything that you should use for your actual sampling. And I think that's what we want, I think. When we go back and do the, look at how this is going to go. So what we want to do is see, compare effectively. We want to take and look along the axes. You know what? We're out of time. We only have 2 minutes. I'm not even going to talk about this. We're going to do that tomorrow, but that's effectively what we're going to do tomorrow. And then we'll move on from there into actually using the thing, right? I think we're okay here if I just compile, so we left it all right. All right. So I'm going to go ahead and go to Q&A. How far along in the game are we? What percentage would you say? We're almost done with the engine. So, I mean, I guess what I would say is we're almost 100% done with the part of the stream that is the part that I wanted to do, right? Which is building a game from scratch, technology-wise. In terms of what remains after that, normally you would say, well, it's 0% done because you have to make the whole game then after that. Because that's the game design part of things. And that part, I will not, like, I'm going to go do a game, but that, like, I can't, at that point the stream it's not over, but it's sort of functionally not really something I can help you with. It's not something I can really teach. So at that point it's like, hey, I taught everything that I can teach, and now we're just like building a game so we can say that it can run a game, right? But I can't really teach it. Because, it's not really the kind of thing that I do. Concerning picking lighting probes, could you use some sort of proximity hash, for lack of a better term, if there is such a thing, something like where the key would be the location you want to select from? Ideally, collisions would be physically close to each other in space. Or is there a reason why doing something like this would not be feasible? Although when I think about it, what I'm describing sounds a lot like a 2D array. Proximity queries always have to, that is what we're doing. And when you say proximity hash, it's like, well, the only way to really do a proximity hash is to search some percentage of the entries in the hash, because there's no such thing, as far as I know, as a proximity hash where you just like fuse the values together and then you always get the right answer in your first probe, right? And so, proximity hash, really what you have to do is just spatially hash and then do a search for things in the neighborhood of the spatial hash, usually. And so what we're doing here is trying to be a little more efficient than that on the lookup side, while being potentially more expensive on the storage side. And the reason for that is we're aiming for maybe running this thing per pixel, and per pixel all we're really going to have, I think, the bandwidth to do is one lookup into a voxel to get the cube we need to interpolate, and then 8 lookups into the lighting info. That's already pushing it, right? Have you thought about fully voxelizing the world and tracing arrays in voxel space? Alternatively, what about selecting the probes using frustum voxels like in Doom 2016? So two things. One is no, I would not voxelize the world in trace race and voxel space. The reason for that is no one's ever actually gotten that working. So if you go look at like voxel cone tracing and stuff like that, it's just simply not fast enough to do all your lighting. Like it's just not. We need to be a lot sparser than that. We need to, and you could argue that maybe if we just did a really low-res version, that would be fine, but I think we'd get all kinds of artifacts. So in order to actually make that run with enough fidelity, I think it's way too dense, and just forget it, right? I mean, that's sparse voxel cone tracing is something you can only really use in like pretty isolated scenarios, I would say, at the moment. Certainly on the kind of graphics cards we're targeting. But as for selecting probes using frustum voxels like Doom 2016, again, not really possible. Reason is because we need our lookup to be based on where the probes are actually placed. The reason Doom 2016's system works is because they're just looking for the closest N lights. So what they do is they say, let me create a voxel, a frustum, voxelized frustum. So basically clip space voxel. And then for each cell of that voxel, I'll just track all the lights that, I'll track the N closest lights and use those, right? But we don't really want that. We want you to have the same, we want the voxel granularity to be about the same as the probe placement, and that probe placement doesn't get sparser as you get further away, right? So using the frustum, I think, would be a bad solution for us, even though it was maybe a good solution for them. Is it possible for you to share your theme color hex codes? Probably. So I think that stuff is in MISC. So I think this is them. I think that's what you're looking at. Will light probes only collect from hits to closest surfaces, and as such, would a 3-level setup per tile always leave the middle one never collecting any light? No. So light probes collect hits from all surfaces. Would you then consider handing the project over to a game designer to continue teaching the next parts? No, because, I mean, the problem with that is there are almost no good game designers. Like, there's probably like 5 good game designers in the world or something like that. And I don't know that any of them would be interested in doing it, right? I mean, if I was going to hand it over to like John Blow to do or something, sure, but he's busy, right? So I don't really think that's a feasible alternative, because I can't think of anybody who I'd actually who would be available who I actually think is any good. The number of good game designers in the world is like almost none. I would say probably most games that I play, I think, are fairly incompetently designed. Like they just weren't thought through. Obvious stuff is wrong. They don't have much understanding of what the player's doing or why it's fun. Like, they're just kind of like, most game design tends to be like mimicry. Like, oh, okay, this is what happened when we shoot things in first person, so we just kind of did that again, right? So in terms of teaching game design, like, I really don't know. Yeah, there's very few game designers that I think are any good, and I don't think any of them would be interested in doing it. Interested is the wrong word. Maybe many of them would be interested in doing it, but simply don't have the time, right? Have you read the recent Morgan McGuire Diffuse GI Probe paper? That's the paper I was talking about when I said I looked into it because I wanted to know what they did for sampling real-time stuff, and I was like, oh, duh, you just use the probes. Are entity component systems really a good way for an entity system? John has said that they're not really nice, but I want to know what you think about them. Yeah, I don't. I would just defer to John on most things about that. He's because entity systems are just about enabling designers. That's the only reason they're there. And so the same thing I just said about how I think most game designers are bad. John's one of the only really great game designers who's also a very skilled, technically adept programmer. So I feel like he's the person you should ask what an entity system should look like, just kind of period. Because he's the only person who A, has the skills to make a good entity system, and B, is the user of an entity system, right? So I would say take his word for it if you don't have your own opinion, right? If you're looking for someone else's opinion, he's the person whose opinion you should adopt. If you just want to know my cursory opinion, I think it's one of those cases of putting the cart before the horse. It's exactly like object-oriented programming. It's prescribing a solution before you have described a problem, right? And so the problem description I would give for how entity systems are supposed to work is that given a particular game design, they should have made it as easy as possible for the developer of the game systems to express that design. An entity component system assumes a bunch of things about a game design and makes a bunch of things hard and a bunch of things easy, right? That split is not necessarily a good one. Right? And so much like object-oriented programming, I think it's the kind of thing where it's sort of like prescribing a solution without really thinking about which problems you were solving or whether you solved them in a way that you should really be telling other people to do without first caveat and saying your problem should look exactly like this if you're going to use this solution, right? Can we do some AI programming for the NPCs? Well, we will do some. I mean, not really probably anything that most people would consider AI, but we will do some for just controlling how how the NPCs like move around and attack you, right? So when we're doing the game, we will be coding the stuff that sort of does that. To use forcoder outside Handmade Hero, I used to. I don't anymore, really. I ended up kind of writing my own editor, and so now I don't, but I did for the past 5 years or so. Basically what I found was when I actually sat down and did a bunch of stuff that I wanted to do in my customization layer, I ended up with something where the whole editor was in my customization layer at that point. So then I just moved it into my own code base because that lets me now do other stuff I couldn't do before. Because now I can like integrate it into all of like my meta code stuff and everything. So obviously I can just kind of go nuts with it. But yeah, which by the way is roughly what I would recommend. One of the reasons I really like forcoder is for exactly that reason. it basically gives you all the tools to build your own editor right from the start, because you can have an editor up and running immediately, but all of the code that you're writing is in C and usable outside of it. So it's basically like, I think of ForCoder almost as like a editor making toolkit. And then if you ever want to go really nuts, you can always then just separate your stuff off from ForCoder someday and go off into the sunset. But if you never want to go that far, you don't have to. You can always just continue to use ForCoder as your base editor and not write all that stuff. So it was kind of optimal for my purposes, and I think that's a really great... I wish more systems kind of work that way, because it would be awesome, for example, to have like a 3D editor that you could start with, and then eventually you just move on to your own thing as you've re-implemented everything that you want. Or if you don't, then you just don't, right? So having that, like, C programmability is just a really big thing that helps a lot, and I really like it, so. Could you share the paper you mentioned about light probes? Yes. So, I think this is the blog about it. Yeah. So, there's two things. One is this blog set here that you can get. And the other is the paper that's in Journal of Graphics Tools. I don't know if this is it. Yeah, this might be it. Yeah, this is the J. Yeah. Yeah. The other is this paper from Journal of Graphics Tools. Those are the ones I was thinking of anyway. Did you talk about Harvey Potter during pre-stream? Yes. You said that at a hit you will store the result in the closest probe. No. So you've got it backwards. Probes shoot rays and record whatever they hit. When you hit, you look up what the lighting is in the closest probes. That's what lets you use your probes as convectors for the light. But you don't use that to say where to store it. Right? MTS Mox, might you need extra reflectors for the sprites to get better collection around those areas? Possibly, but possibly not. Are ForCoder's source slices available to the general public? I think so, but you don't actually need a ForCoder source license. Well, you might up until Alan releases the changes that I contributed back the changes that I needed to allow you to do kind of arbitrary rendering and stuff. But those he's supposed to have mainlined at some point. So once he releases something with those in there, I don't know that you really need a source code license, right? Because you know it's got the stuff exposed that it needs to expose for you to build your own like editing stuff on top, right? And so the number of times I've had to do something in the ForCoder source, it was really only one pass that I did to add sort of hooks out for things I needed. But I contributed those back, and now they will eventually be, anyone will be able to use them. So I don't know that you would really need to negotiate a source code license. That said, I would assume that Alan would be happy to do so. You know, they're just going to be a lot more expensive than licensing it, you know. It's just going to be a lot more expensive than licensing it as an end user. So, you know. If you're a company, though, that's obviously something you should do. I mean, in our case, right, we wanted one because, like, you don't want to be in a situation, like, if Alan just stops working on ForCoder someday, right? You need to be in a situation that you can keep updating it. So up until the point where you're sure you're going to completely move off of it to your own custom thing or something, where you're literally not relying at all on updates to the core. If you're a company, you should license the source because it's going to be relatively cheap compared to the cost of running a company. And then that you just have the ability to do whatever you need, and you can go in a different direction if you need to, or anything else, right? But as an individual, I don't think you really need to do that. Like I said, I kind of already did that work for you. So, unless you're thinking of some particularly saucy stuff that's like well far afield from the kinds of mods I made, which I don't know what other people, I guess maybe other people are thinking of things that are really wacky compared to what I wanted to do. But in terms of just being able to draw some stuff to the screen with your own like rendering primitives, I basically added some stuff for that. And it's not crazy. Like you can't, so, if you wanted to do like images and stuff, I guess that never made it in there. But other than that, I think it was pretty good. More Jeff and Casey show episodes soon. Yeah, so it really depends on Jeff's schedule, but the hope was yes. Obviously, we just released one last week. Well, actually, this past week, however you want to say that, on Monday. And so we probably won't be able to release one like every week, but we do hope to have one a month or something coming out now. Why only PayPal and credit card payment methods for Hammer Hero? What other payment methods did you want? What do you think about a purpose-built editor as opposed to a general-purpose text editor could work directly with a binary format similar to any other content creation tool? Yeah, like I said, that's what I did. Oh, Bitcoin? So the reason that we had Bitcoin, the reason that we don't have Bitcoin anymore is because the transaction cost for Bitcoin ended up being more than the cost of Handmade Hero. Bitcoin just doesn't work. It's a fundamentally broken system. They're trying to fix it, but it's not good. And so the Bitcoin providers that we were using to accept Bitcoin payments just couldn't do them anymore. So they're just not available. Wasn't our decision. That just option went away. Apple Pay, so I don't remember what the reason is if Apple Pay is not on there. I think it had something to do with the fact that there were certain, because I thought Stripe allowed Apple Pay, but there were some things we had to do that I wasn't thrilled about. So Apple Pay may happen, but it may not. I'm not sure. But Bitcoin we had. And Bitcoin just collapsed on itself and doesn't work. So that's why it's not there anymore. Cryptocurrency. Gonna take over the world, right? Can't buy a frickin' $15 product with it. But no, it's great. All right. Why are you listed as Rewind Evangelist in Braid? The reason I'm listed as Rewind Evangelist in Braid is because I think the story goes something like John's original idea for Braid he had whilst reading or thinking about a post I had made to a mailing list about Rewind. So I really didn't have, I want to say, anything to do with the design for Braid. Like on the Witness, I remember talking with John about some puzzles, even some important puzzles, and I didn't really have much to do with the design of that game either, but at least I had some discussions I remember having about it. Braid, I feel like I literally had no contribution to the game design whatsoever, even in that sort of passing sense of having talked through a problem with the designer when they were working on it or something. Like, none at all. But the reason, at least I gather from John, that I am listed with a credit in that game for some reason was just I had made a post to a mailing list where I was talking about how games in general should just have rewind because, like, it treats my time as a player as more valuable in, like, look, I don't want to have to replay this section of the game if I don't want to. Like, why should I? I already did it once. It's not going to change, right? And so a lot of games in that time, like this is, talking not about roguelikes, but like of like AAA games where you just have to do this set of things. I'm like, why do I have to do this set of things again? I already did it. You're just making me do it as punishment for not knowing how to do the final thing, and off we go, right? And so it was just me complaining about why games just didn't just have rewind in general, because that would just make it more enjoyable for the player to play these AAA games, which maybe is just a statement about the fact that the AAA games suck. I don't know. But that email apparently was somehow related to John thinking up the idea for Braid, or maybe it crystallized some aspect of it. I don't know. You should really ask John. It's probably more credit than I deserve. The only meaningful contribution I actually made to Braid was a code contribution. The collision detector, the rounded rectangle collision detector in there is my code. So really the only credit I should have gotten was like some kind of like additional programming by kind of credit, but instead I get a very prominent credit as Rewind Evangelist, which I was for that email, but I didn't yeah. I guess that's just a really long-winded way of saying ask him. I'm not really sure why I had that. I don't know why I got that credit. I absolutely 100%, in my memory, had no design input to Braid whatsoever, even like a passing conversation with John about a puzzle. Like, I don't remember a single thing that I ever said to John about the design of Braid that had anything to do with designing Braid. Like, as far as I remember, he designed it and I played it, and that was it. What mailing list? It was some game design mailing list thing. I'm not on it anymore. I don't even remember what it was called. Sounds like you wouldn't be a fan of the current Souls-like trend. No, so I'm okay with games that are about execution. For example, I loved Abin Hawkins and the 1001 Spikes because that game is about execution. That is what the game is about, right? It's not about exploration, it's not about talking to NPCs, it's not about solving puzzles. It's about executing the line, right? And getting really optimized at executing that. And that's what it's about. It's unapologetic, right? And so I'm totally fine with no rewind in that game because the game is about being it's like a being a gymnast, right? It's about learning to execute exactly every time. And so I'm totally down with that. But the problem is a lot of games, Legends of Zelda, The Witcher, or Red Dead Redemption, or maybe not Grand Theft Auto as much, but even Grand Theft Auto, even first-person shooters, Call of Duty, blah blah blah. They're just not about that. They're just not about execution. They're about playing through a scripted scenario. And when I play through the scripted scenario, and the game is 3 easy dudes and then a really hard dude, and I never die on the 3 easy dudes, and I die on the hard dude I don't know how to kill, and you make me play through the same 3 easy dudes for no reason every time, that is just not... And nothing I do about those ever improves. Like, I don't... You know what I mean? That was the big thing about Abin Hawkins, was like you learned to refine your movements to make it very unlikely that you would die in all the places, and that felt really good, right? And that, if you don't have that aspect to your game, it's just frustrating and annoying, right? So I don't necessarily have a problem with games that are about that, or like roguelikes like Binding of Isaac, where each run is unique. Totally fine, right? Because at that point, it's like you're not making me play through exactly the same thing for no reason. But if a game is mostly about making me play through the exact same thing for no reason, I've got a problem with it. I never played Dark Souls, so whether I would levy that complaint at Dark Souls, I'm not sure. But, hopefully that explains a little bit more. All right, I'm going to wrap it up. All right. Thank you everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always go to handmadehero.org and pre-order the game. It comes with the source code, so you can play around with it. We'll be back here same time, same place tomorrow, I believe. So at that point, we'll start to look at actually implementing that lighting. We'll have a full 2 hours so we can start to make a dent in it. But again, it's probably not going to be a one-day thing. We're going to have to spend a few weekends on it for sure. Lighting's very complicated. It's one of the hardest things you can do in graphics. So we're just going to take a little bit of time. That's fine, but just be advised. So we'll start taking a look at that. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.